Okay, this tutorial is going to be about VLANs and trunks. Now, I'm using Packet Tracer here, and I've got a switch out here, and I've got two clients. And basically, a switch is used to create local area networks or LANs, and it's used to interconnect PCs on a LAN, right? So you've got this PC at 192.168.1.100, and this PC at 192.168.1.101, and we're going to connect both PCs to this switch, and then they'll both be on the same local area network. So I'll take the cables and I'll cable this switch right here, and we'll put this guy into port, let's say 5, and we'll put this guy into port fast Ethernet, click, and then we'll put this guy on port 10. So now both PCs are on the same LAN and they can talk to each other. So if I go into PC 101 here, open up a command prompt, I can ping the other PC at 1.100, right? I can send an echo request and get an echo reply, and we're on the same local area network and we can communicate, partially because we have the same network address space. Now, what we can do is, let's take a look at this switch and start talking about VLANs and trunks. So, first of all, the Cisco switches are set up by default so that every port on the switch is already part of the default VLAN, which is VLAN 1. So that means if we go into the switch, and we'll go into the CLI, command line interface, and we'll type enable, and we'll do show VLAN as a command from the privileged user mode. You'll be able to see that by default, with the show VLAN command, that VLAN 1 is the default VLAN. It's active, and notice all the ports on the switch are all part of VLAN 1, right? And then you can see we've got some other built-in default VLANs here. We've got VLAN 1002, 1003, 4, and 5, and 2 is for FDDI. 1003 is for token ring, and then you've got another FDDI and another token ring, and these are there for basically backwards compatibility with these older forms of networks, right? And you cannot delete these. These are the defaults. So you cannot rename VLAN 1. It's always going to be the default VLAN, and you cannot delete VLAN 1. And same goes with these other VLANs. Now, so these are the built-in VLANs that come ready to go on the switch. So if you just plug your PC into the switch, you're already part of the default VLAN, and all of the ports are assigned to VLAN 1. So what we can do is we can create additional VLANs. So what we can do is we can say conf t, short for configure terminal, go into global config mode, and we can say VLAN 50, right? And then now notice we are in config-VLAN. We're in VLAN configuration mode. And now we could say, look at the commands that are available. You can see name is available, also the no command to get rid of the VLAN. But we'll give it a name. So we'll say name, we'll call it student, right? So there we go. We've got now name student. We have a VLAN 50 and its name is student. We can also do another one. Let's say VLAN 99, right? And we could say name, and we could call this one MGT for management. So now we've created a VLAN for, let's say, management. All right. And let's exit. And we'll do a show run. I didn't want to do that. Let's do a show VLAN. And now you can see that we've got the 50 student VLAN and the VLAN 99, the management VLAN now. And they're both active, but no ports are assigned to them, right? So the next thing to do, once you have created a couple of VLANs, is maybe to assign them to some ports. So what we'll do is we'll say, we'll put this PC right here, 101, who is on port 10. We'll make port 10 part of the student VLAN. And let's see what happens if we do that. So we'll go like that, and we'll say interface FA. Well, first we need to go to configure terminal, or conf t for short, to get to global config mode. Then int tab, which is short for interface. FA tab, which is short for fast Ethernet. 0/10. Now we're in interface configuration mode, right? And we'll say switch tab, switch port, mode, access. We can make it an access port, all right, as opposed to, let's say, a trunk port, which we'll be talking about in a minute. And then we'll say SW tab, switch port, access, VLAN 50. Okay, so now we've just assigned that port to that VLAN. Now I'll say end here, and I'll do a show run tab. Oops, show run tab, which is running config, and you can see now that port 10 is now part of VLAN 50, right? Switch port access VLAN 50, switch port mode access, right? So now port 10 is on a different VLAN than port 5, which is part of the default. And you'll see here, let's do one more. We'll do a show VLAN, and you can see that now VLAN 50 has port 10 assigned to it, right? Now, if we go back to our two PCs that have the same IP address range, 1.100 and 1.101, they will not be able to communicate with each other because this port, port 5, is in VLAN, the default VLAN, which is VLAN 1, and this port, port 10, is in a VLAN that we just created called the student VLAN. So we'll do that same test, and we'll see that it fails, right? I'll go to ping 100, and you'll see that now I'm unable to communicate with the other PC because I'm on separate VLANs, right? So when you assign VLANs to switch ports, different VLANs, you're basically taking the switch and creating separate LANs, hence the name VLAN or virtual LAN, right? So instead of just one local area network where all the PCs can plug into the switch and communicate with each other, it's as if right now these two switches are on separate networks. So if this PC is on VLAN 50, it's going to be more appropriate for maybe its IP address to be 192.168.50.101. And so we can do that just to show that, in fact, this PC is no longer on the same LAN as the other PC. So I'm going to do that. I'm going to change its IP address to 50.100. Since they can't communicate anyway, what's the point of having them in the same IP address range? They're essentially on separate networks because they're on separate VLANs. Once again, this is here the default VLAN, which is VLAN 1, and now he's on VLAN 50. So they're on essentially two separate networks, and they're unable to communicate. Now, they could communicate with each other with the presence of a router to route across the switch between the two separate networks. Or if we had a layer 3 switch, which could basically handle the routing itself from within the switch. But we don't. This is a layer 2 switch, and it's got separate VLANs now. It's got ports on separate VLANs, so the two PCs are unable to communicate.